Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. In this video lecture, we will study Stirling formula. The Stirling formula is again a central difference formula, and it is simply mean of goes forward and goes backward interpolation formula. It is mean of goes forward interpolation and goes backward interpolation formula. Okay, so firstly we shall be writing both goes forward interpolation and goes backward interpolation formula, and then we'll taking their mean. So to write them, we need to write a table, and from that table we will refer the coefficients and the other terms that will be involved in the formula. So how will construct the table? Let us take the y naught as a central value and move it from here to in the upward direction, in this direction, and say this is first delta y. Also move in the downward direction, say this is first delta y. Now both will move converge to single delta square y. Now move in the upward delta cube y, delta cube y, this will be delta 4 y. Fine. Now see, when we move in the upward direction, energy is required, so this will be here subscript is 0, so this subscript will become -1, 1 less. When we move in the downward direction, it is very easy to move from upward to downward direction, so lesser energy, or almost you can easily move from upward to downward direction. So from up to down, you in the downward direction you can easily move. So here is 0, so here it will remain 0, and if here is 0, you will move in the upward direction, so this will be -1, and when from -1 to here you will move in the downward direction, so it will remain the same. Again upward it will be -2, and when you move downward it will remain the same. When you move upward it will be -2, and when you move downward it will, and so on. You can continue. Fine, you can continue, so on. So now from here we will draw a horizontal line. Okay, and below that line I am going to write the coefficients 1 u, 1 u2. Now increase u by 1, that will be u plus 1, 3. Its next term will be same, u plus 1, and 3 will increase to 4. And here write the coefficient 1 u1, and after the second term increase u by 1, u plus 1, subscript 2. Now it is u plus 1. It will remain same for two terms. For one term it is this one. For next term it will also u plus 1, and here will be 3. Now increase it by 1, because for two terms it is same u plus 1, u plus 1. Now increase it by 1, it will be u plus 2, 4, and something like you will go on writing. If you will, from here you will write the next one, u plus 1 is same for two terms, so here will be u plus 2, and of course 4 to 5, subscript 5. So here the difference between these coefficient and these coefficient is that in this, the lower coefficients, we increased the value of u after 3 terms, and here we increase the value of u after 2 terms. So for writing the forward formula, we will use the coefficient along the line and below the line for forward interpolation formula. And coefficients along the line and above the line are used for backward interpolation formula. So I have made it clear that how we have written all these terms and these coefficients. Now I am going to we know from Gauss forward interpolation formula, write y, x, of course, function of x, y naught plus u1 delta y naught plus u2 delta square y minus 1 plus u plus 1 3 delta cube y minus 1 plus u plus 1 4 delta 4 y minus 2 plus, and so on. Okay, what we have used along the line coefficient written and below the line. For this coefficient multiplied with y, this one, this delta y not multiplied with this coefficient, this is multiplied with this one, this one, and so on. We have written Gauss forward interpolation formula. Gauss backward interpolation formula what is that? It will be yx. Try to write the terms below this one, exactly below. It will be y naught plus u1 coefficient, upper coefficient now, and above the line delta y minus 1, exactly right below, so that we can take the mean, u plus 1 subscript 2 delta square y minus 1 plus u plus 1 subscript 3 delta cube y minus 2, this coefficient and this one multiplied Next is plus u plus 2 4, it will be delta 4 y minus 2 and so on. Now taking the mean of 1 and 2, what will get? Yx plus yx by 2. This is the mean. Here y0 plus y0 by 2. Fine. And here u1 will be common. Inside will be delta y0 plus delta y minus 1. This one, this is common and divided by 2. Fine. Here u subscript 2 plus u plus 1 subscript 2 and outside is delta square y minus 1 and this is divided by 2. Fine. Similarly, this one will be u plus 1 subscript 3 will be common. This will be delta cube y minus 1 plus delta cube y minus 2 by 2 plus u plus 1 4 plus u plus 2 subscript 4 outside is delta 4 y minus 2 and divided by 4 mean, because we are taking the mean, so we are dividing it by 2, like here. Add up and divide by 2, add up, divided by 2, add up these two terms, divided by 2, add up these two terms, divided by 2. So now what is u2? U plus 1 2. You know the formula. This will be y0. Fine. u1 and it will be 1 factorial delta y0 plus delta y minus 1 by 2 plus, now this formula is u, we have already done, it will be, you have to manually do it. So we will be solving this one. So what will be this? This will be u minus 1 by 2 factorial plus u plus 1 u by 2 factorial and outside will be delta square y minus 1 by 2 plus, what is u plus 1 3? It is u plus 1 decrease by 1, once again decrease 3 terms, divided by 3 factorial. It will be delta cube y minus 2 by 2 plus, here we can write u plus 1 u minus 1 u minus 2 divided by 4 factorial plus u plus 2 u plus 1 u minus 1 by 4 factorial and outside is delta 4 y minus 2 up to so on. Okay, so now this is further equal to y naught plus u by 1 factorial delta y naught plus delta y minus 1 by 2 plus take common out, u by 2 will be common. Inside we are left with u minus 1, u plus 1. This will be 2 factorial is also here, you can write it, y minus 1 by 2 plus u as such, u plus 1, u minus 1 will be u square minus 1 square. Fine. Delta cube y minus 1 plus delta cube y minus 2 by 2, and here is a 3 factorial. Fine. Take the common out, u plus 1 is common, u is common, u minus 1 is common, so we are left with 4 factorial is common, so we are left with u minus 2, u plus 2. Fine. And it will be, of course, here is also divided by 2. Okay, so this will be delta 4 y minus 2 by 2 up to so on. Now this will cancel out, this will cancel out, so it will 2u, and 2 to 2 will cancel out, so it will be y naught plus u by 1 factorial delta y naught plus delta y minus 1 by 2 plus u by 2 factorial, it will be 2u delta square y minus 1 by 2 plus u square minus 1 square by 3 factorial delta cube y minus 1 delta cube y minus 2 divided by 2. Fine. And this will be 2 will cancel out, plus u plus 1 u minus 1 by 4 factorial, and it will be 2u delta 4 minus 2 by 2. This 2 will cancel out, and so on. So this is further equal to y naught u by 1 factorial delta y naught plus delta y minus 1, and 2 to 2 will cancel out. This will be u square by 2 factorial delta square y minus 1 plus u square minus 1 square divided by 3 factorial, and it will be delta cube y minus 1 delta cube y minus 2 divided by 2 plus u plus 1, u minus 1 is u square minus 1 square. This u will be u square by 4 factorial. This is delta 4 y minus 2 up to so on. So this is your yx. So which is the required Stirling formula? Required Stirling formula. And this formula used when u lies between 1 by 2 and minus 1 by 2. So this formula will be used. So this is central difference formula. And how will you write the formula with the help of the table? I am going to write the coefficient y naught, move in the upward direction, move in the downward direction. So in both cases you write delta y now converge to delta square y downward. This is upward. Now move upward, move downward. Fine. This will be delta cube y. This will be delta cube y. Fine. Move downward. Fine. Delta 4 y. Now when we move upward, energy is required, so 0 will become -1. When we move downward, no energy is required. You can easily move in the downward direction, so it will remain the same 0. When move upward, 0 to -1. When move downward, -1 remain the same -1. When move upward, energy is required, so it will decrease by 1. When you move downward, it will remain the same. When you move upward, it will, and so on. You continue going something like that, and coefficient will be 1 u degree 1. How will you make degree 2? Multiply it by again u degree 2 degree 3. How will you make degree 3? It will be u square minus 1 square. 2 degrees okay, and multiply with u degree 3 divided by 3 factorial. Now you have to make degree 4. How will you make degree 4? Multiply it with one more u. This will be u square minus 1 square by, it will be 4 factorial. Now how will you make the degree 5? So you can easily write the other term coefficient if you want. U square minus 1 square. Next will be u square minus 2 square, and here will be u by 5 factorial. Next will be u square minus 1 square, u square minus 2 square divided by 6 factorial, and so on. You can continue. So the coefficient I have explained you how to remember them. 1 u degree 2 u, with the help of u square it can be degree 2 by 2 factorial. Degree 3 u square and u term, but u square cannot be same because it will make u cube. So u square minus 1 square. Degree 4 supply u square. Degree 5 1 u and 2 u square, and 1 u square in the form u square minus 1 square, another u square minus 2 square. And in the next term supply this. If you want to write another one, it will be u square minus 1 square, u square minus 2 square, u square minus 3 square by 7 factorial, and continue something like you go on. Now take the mean of these two and multiply with the coefficient. So from here if I write yx is equal to y naught into 1 will be y naught plus u by 1 factorial. Take the mean of these two. Fine. Mean means divided by 2. Now this will be u square by 2 factorial. Simply multiply delta square y minus 1. Now plus u square minus 1 square divided by 3 factorial. It will be delta cube y minus 2 plus delta cube y minus 1 by 2. Okay, and mean divided by 2, mean of these two, and plus u square minus 1 square divided by 4 factorial into delta 4 y minus 2, and so on. So this is the Stirling formula, and how if we have to do the numerical problem, we will be writing it with the help of this table. So in this video lecture we have studied the Stirling formula, and it is used when u is between minus 1 by 2 and 1 by 2, and this is a central difference formula. And in this video lecture we also studied how to write Gauss backward and Gauss forward interpolation formula with the help of the table, and we have taken their mean to derive the Stirling formula. It is very easy, so I hope you will be able to understand it. So that is all I have from this lecture, and if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.